Good day, my name is Gary Leong, the Director of Industry 4.0 and Ecosystem Development. Today we are very excited to have this webinar whereby we're going to share to you our artificial intelligence in imaging for AOI. So in ViTrox, we've been dealing with AOI for many years, and artificial intelligence will be the forefront towards the future. In our department, I'd like to introduce you our two subject matter experts, Mr. Khoo Yak Hua as well as Mr. Marcus Wong. So our first speaker, Mr. Khoo, has a lot of experience in the vision inspection industry. He has combined 4 years in the PCB, as well as 2 years in the AXI, and 7 years combined in the AOI industry. So with us, he's specialized in the image processing as well as artificial intelligence. He will speak to you later about AI assist buy-off in repair station. For our second speaker, Mr. Marcus Wong, very experienced. He has 12 years of experience in ViTrox. With that, he specializes in the image processing and 3D construction. So he is in charge of the ViTrox 3D AOI machines and very passionate, and he brings his passion into the work as well. And his topic will be on AI smart programming. Okay, without further ado, we will go towards right to the topic, AI assist buy-off in repair station. So our first speaker, Mr. Khoo Yak Hua, will explain more on this topic. Thank you very much.
Thank you, Gary, for the introduction. AI is not new to now. We can backtrace into 1943, where the first neural network being invented. And then back then, many years later, on year 2009, a very famous Prof. Lee Fei that from Stanford launched the first ImageNet. That is the first convolution neural network that bring a lot of hoo-ha in the industry. That accuracy is impressive. Back to a few years later, 2011, the AI is being more and more famous. So at that point of time, here comes the hardware acceleration GPU technology. A combination between the GPUs, hardwares, together with the deep learning convolution neural network, combination together, it makes the real life really practical into implementation into the real world application. Until today, we can say that everything is going to be AI. So AI being chipped into many of the different industry, including oil and gas, food and manufacturing. So today, we are going to talk about the repair review station. So later on, my colleague will be talk about the AOI. This is the current production situation. Today, we still require human operator to assist the machine in order to do the final review. Sometimes, when the production have any part change, for example, the engineers is not able to assist the machine to real-time do the fine-tuning always. Sometimes engineers tend to be busy doing all the other production work. So as a matter of fact, eventually there are too many forced reject from the AI that it might causing the yield loss. So the manufacturer, they decided to put the operators, human, to review the final judgment of the vision inspection defect call to improve the final production yield. So this will lead to the loss of the weightage, and the cost for the human operator can be high. And the time consuming for the VVTS, the repair station buy-off, it can cause out the low productivity in the production. The more serious case would be the mistake that actually happen in the production floor. So humans sometimes can be emotional. So when they do the review, if they made the mistake, there will be some of the defects that go into the back end that it will eventually cause a lot of for you to do the repair. Basically, when the human, it can be emotional, and sometimes when they make the mistake by wrong judgment on the calls, it will cause the back end have a higher cost of the repair. So in this case, we would like to introduce our new AI assist buy-off. So our direction was we are trying to replace the human by the artificial intelligence. So this is the interface. You can see that it is the left-hand side is the defects, and then the right-hand side will be the defects list. Now, there is a new column, we call it AI buy-off results. So you can see that it is showing that this is the component, and in the conventional way, human will require to take a look on is this the actual defects, or is a false alarm, or is a part change. when we implement the artificial intelligence, we use a lot of data to train. The model is now capable to recognize the SMT part. As a result, that knowledge is now being learned by the AI model to help the operator to do the judgment on that particular defects. So we have a few different scenarios here. Let's take a look. So this will be the overall different scenarios that happen in the automatic assist buy-off. So from the AOI, whenever there's a defects happen, it can be the actual defects, which is the bad one, or it can be the good one, which is, we call it AOI false call, the false alarm. So when all the defects is coming from the AOI, it will eventually go into the AI convolution neural network model that trained by us, and then that particular model will judge whether this is a OK or NG. So the good component we can judge as OK or NG. If we judge it correctly, that is correct prediction. When there's a good component, the AI say this is a false call, this is an NG, it will become AI false call. Whereas the other case, when the component is the bad one, when the AI say this is good, this is what we call it AI escape. And when they say the bad one, AI have the correct prediction, we will say it as NG. In the right hand side, you can see that we have the mode 1, mode 2, 3, and 4. So the mode 1 is basically the most basic mode where the machine, the application itself, it won't do any of the judgment. It will prompt up the columns for you. It will tell you what exactly that particular defects result predicted by the AI. The human will still go through all those defects no matter how. The mode 2 is totally turn on the AI buy-off. No matter the AI say pass, it will pass. The AI say fail, it will fail. This is the ultimate goal that we want to achieve. The mode 3 is whenever the AI says that component is passed, then that particular component will be continued second review by the operator. Whereas when the AI says that component is failed, we will no longer allow operator to buy off so that we can prevent the mistake from the operator. The mode 4 is the most common mode that turn on in the production floor right now. So whenever the AI say this component is a pass component, the operator no longer will review over that particular component. Let's see what is the rationale of this particular mode. Why mode 4 is more practical for the production. So this is the comparison between AI and human. The human thinking, whenever the operator do the judgment on the AI, on the ViTrox review station, human tends to make the defect pass. So why? They would like to do it pass because it's easy to handle, pass because it will eventually bring your line to be a better performance, but that is not real. Sometimes when you make it pass, the escape go to the back end, it will eventually cause a lot of rework, costing in order to repair that particular component in the later process. So the manufacturer found that is quite a serious issue today. The human also, they tend to just make it pass whenever they don't really know what is that, they just make it pass. So whereas for the AI design, it is the other way around. Whenever the AI doesn't know what parts is that, it is really, really different from the parts that is supposed to be look like this, but it looks a little bit different. The AI will tend to make it fail. When the AI make it fail, eventually you will have lesser escape to the back end. And as well as whenever the AI, in the case that the AI make some wrong judgment, it will still go back for the human to do the final judgment. So that is the mode 4, what's happening today. Whenever the AI say fail, it will go to that particular operator to do judgment. When the AI say pass, the operator will no longer see it in the repair station anymore. So this is how we reduce a human mistake and how we reduce the human workload by automatic buy-off from the AI. There are a very different way of how we build our convolution neural network. The left-hand side will be the conventional AI. So typically when we train a convolution neural network, we will collect a lot of data. We will do all the labeling. This is, for example, this is a bad joints defects. This is a OCV defects. This is a missing defects, and so on. So we will need to collect all those defect images, do the labels, put it into nice category, and then we go into the convolution neural network to do the model training. Finally, after train, it will come out the AI model that we put into the machine, and then to do the prediction. Whenever the prediction having some wrong judgment, we will need to take the image, go into the convolution neural network, and retrain again. So this is the conventional way of running deep learning AI. Whereas for ViTrox, we already tried the conventional way. It works, but it doesn't really practical in the production floor. The reason why was production could happen any kind of different defects. Later on, we will show you some of the example. So that particular defects itself, whenever there's a new defects happen, it will require to go into the model and retrain. Whereas for the right-hand side for ViTrox AI, we use a different approach in order to train the convolution neural network. So you can see from the charts at the right-hand side where the AOI itself, it will automatically submit those images to the AI. Then the AI model, it will on-the-spot real-time learning. So with this approach, once it extracts all those important features from that particular image, it will convert into the AI knowledge. So from there, the next bot coming in, the AI is able to on the spot do the judgment whether this particular component, it is a good one or there are some defects on it. We actually reduce the frequency of retrain the model. Retrain the model sometimes can be very time consuming. We have been tested in the past 2 years in the production floor where the retrain frequency is too high. The production performance on the AI can sometimes be high, low, and then up again after retrain and low. But by using the new invented technology from ViTrox, we basically reduce the training cycle. Every quarter we need only to retrain one model, whereas within that particular quarter, the performance of the AI could be stable for below 1% SKP. This is some of the different scenarios that the AI detected. So the AI will predict this particular image as failed. So from these images, you can see that there are various kind of different scenario of failure from the production. So if we use the conventional way, where we will need to collect tons of defects images from the production floor, it is sometimes may not be possible. When there's a new defects happened, in the conventional way, you will need to retrain the model that it may cost you 2 days. But the production today, they couldn't afford 2 days to retrain the model. So this is why it makes us so successful into many of the customer adoptions on the current AI, the automatic assist buy-off. So with that, I would like to conclude that in the past, all the ways we required the human to assist the machine to do the final judgment in order for the manufacturer to improve their final yield. Today, we have our automatic assist buy-off artificial intelligence review station to assist the operator to offload 80% of their workload. With that, we still not 100% into full coverage today. We are pursuing to that path. So we believe that in the future, in the coming 1-2 years, when we reach 100% coverage on all the AO artifacts, eventually we are trying to remove the operator. So that is our final goals that we are pursuing today. As a conclusion, with the automatic AI assist buy-off, it could eventually reduce your operator costs, your operating costs. It will save your time into the review judgment. So with that, I would like to conclude my sharing today. Thank you very much.
Thank you, Mr. Koo, for the fine sharing. So if you have any other questions regarding the AI assist buy-off in the repair station for this topic, fill in your questions over in this webinar. Without further ado, I'd like to go towards our second speaker, Mr. Marcus Wong. He will speak more towards on the AI smart programming. So over to you, Mr. Marcus.
Thank you, Gary. I'm Marcus. I'm the R&D manager from ViTrox 3D R&D team. I'm glad I'm given this opportunity to present our exciting new technology, which is AI smart programming. Before I start the sharing, I would like to share how we actually start this AI journey. I remember a few years back when I have been working with the production engineer in the production floor. Our fellow engineers are spending a lot of hours to set up a good algorithm to inspect all kinds of products to get all the defects. During the NPI production, they face tremendous pressure to complete the AI programming within the short time frame. On top of that, we also have to spend a lot of time to ensure the inspection programming is good and able to capture all the defects. Then we started to think, if we can automate the programming, the engineer that handle the programming with ease, they can focus to improve the product quality. It's fantastic. If we can automate the programming, the AOI engineer will have more freedom to develop more productive skill and grow their career. Fantastic. If we can automate the AOI programming, the inspection will be always stable and able to capture all the defects with minimal false call. Can help the company to save the cost while also improve the product quality. Fantastic. In short, if we can automate the process, it can improve the product quality, product consistency, and also save a lot of costs. Without further ado, please let me start the sharing with AI Smart Programming Overview. So to begin with the ViTrox AOI programming overview, first we will have to have a CAD to start with the program. Then we need to prepare a good board. With these two items loaded in the machine, first thing we need to decide what is the IPC standard required for that specific product. Once this is decided, the AOI will help you to detect the fiduciary with the AI fiduciary automatically. Then we will have the AI programming coming in after this. In the AI programming, we will have AI programming phase 2, phase 1, which cover up to 17 types of S&T packages. Then after this component is trained, we also cover the AI EOCV programming automatically. For the AI programming phase 1, we are actually cover chip resistor, chip capacitor, resistor network and capacitor network, QFN, SOT, QFP, and BGA. For auto programming phase 2, we have SOD, inductor, LVD 4 terminals, 2 terminals, ECAP, crystal 4 terminals, and crystal 2 terminals. So now, I would like to share how are we actually doing the AI, how are we actually designing the AI. So first, we have designed two types of AI model. The first model responsible to classify the good and the bad inspection parameter. The second AI model, it has to responsible to generate the inspection parameter. So we collect all the data about the good and bad images and do all the labelings to prepare for this training. Next, during the training, the AI Model B will always generate all kinds of inspection parameters. This time, the AI Model A will take the responsible to decide which is good, which is bad, and guide the Model B. So with this process going on repetitively, the AI Model B will eventually train until they can consistently generate the good inspection parameter. When the AI Model B is matured, with the images, 2D or 3D images going into the Model B, it can automatically generate a feasible and good inspection parameter. So how is the application looks like? So we have three simple steps. First, we prepare the CAD, then we prepare the physical board, then we decide the IPC standard, then these three input put in the AOI and have the AI Model B ready. The AI Model B will assign the inspection parameter automatically. It is also able to classify whether they are capacitor, for example, capacitor, they can tell this is a capacitor 0201, 06, 03, 08, 05, and etc. And all of these are automated. So once the algorithm is assigned and generated automatically, it actually will cover all kinds of defects detection. For example, for a capacitor, it will know the body dimension, the body height, and know where to check the shoulder joint inspection. So with this, we can detect defects such as absence, coplanarity, insufficient shoulder or non-wetting, body offset, and tombstone. Aside from the chip capacitor, we can do it for SOIC, resistor network, SOT, ECAP, for example, they can know all the body dimension, the geometry and their properties. And then for SOIC, for example, we know the body dimensions, we know the body height. We also can learn what is the lead length, lead width, and lead height for the lead. So after this, we can lift the lead very easily. We fully utilize the advantage of 3D AOI. So I would like to show you a real demo of the AI programming. So first, we're going to try on the inductor. So after the AI train, they will not only train the inductor, you also train the OCV on top of it. So you will see the inductor OCV is trained. So for a diode, you also just click the AI train. It will train the diode with the OCV on top as well, which you can see the boxes in the middle. So next, we're going to have the AI checker. First thing we have to do is we have to decide what is the IPC standard that we want. For example, IPC class 3. With this setting, we will automatically detect what is the component that in risk automatically. The problem is highlighted at the right side. For example, the QFN have a coplanarity risk inspection. So with one click, we'll fix the parameter and it is updated in the database automatically. So next, for ECAP, for next example, they have location offset problem. So we just click a fix button, they will improve the threshold for offset automatically. So then it will help to make the inspection software consistent. With the introduction of AI smart programming, so what have we actually achieved? First, the AI smart programming improved the programming time for the SMT line. Second, the AI checker, it will always help us to ensure the production inspection program in a good shape and always able to detect all kinds of defects with the AI checker. This will definitely improve the product consistency and product quality. So thank you.
So the artificial intelligence in imaging for AOI, we have two important features over here. The AI assist buy-off in AOI repair station and the AI smart programming. So what's the value proposition for you? So if both are combined together, this AI power will bring you the quality program created at a very short amount of time with AI assist in buy-off, therefore reducing your manpower and costs in your SMT production inspection. Now we will move on to the Q&A session. Just a reminder, please be sure to submit your questions. Meanwhile, we would really appreciate if you could spend some time answering the webinar question poll to express your experience with us today. There will be a pop-up on your screen with the survey poll. Kindly take a few moments to answer them while we continue with the Q&A session.
Smolder by the flames, dreams crash and burn. Gold are in the ashes, you will learn. Just so you thought all good things come to an end. That's when the new chapter just began. We have rambled through the thick and thin. What is marching brave beneath our skin? Be prepared for the roller coaster ride. Brad, know my love, I'll be by your side.
Okay, thank you for participating in the survey poll questions, and then we really appreciate your participation and also sending quite a many questions over here. So perhaps I can just read the first one, and I will have the subject matter experts to answer to you. Okay, let's have the first question. Any case study success? Any case study success for AI programming to be shared? Perhaps this will be answered by Marcus.
Thank you, Gary. So basically, we have tried this in several evaluations, and so far, especially for the top side, we have achieved like 70 to 80% for the coverage after the auto programming. And for the bottom side, we have actually covered up to be like 90% and above easily. So I think this is the actual happening in the field.
Well, thank you, Marcus. Let's go to the second question. False calls are a common phenomenon in the AI systems. How does the false call impact the AI system? So perhaps this to Mr. Cook.
Thank you, Gary. So yeah, I agree that false call is quite common in most of the AI systems. So in the past, when we are starting to work on the AI, basically we take a lot of efforts into cleaning the data. This is due to sometimes the false call data may be the correct, really the AI false call, or probably is the wrong judgment by operator. So in the past few years, basically we collect all the data and then we train that model into as for today, the model is able to recognize the important features for each of the different packages in the SMT. So we will use the features to decide whether it's a good or a bad component. So today, the false call of the operator will not take into consideration for the AI system. Thank you.
Thank you, Cook. Now let's have the third question. Okay, how many defect samples needed before CNN, as in convolutional neural network, update and retrain that apply back to AOI? So again, this is to Mr. Cook again.
Thank you. So for the quantity of images, basically we could counted like more than 500,000 of the data being collected from various defects type, various packages, and various lighting conditions. So we utilize those data to train the model that able to recognize SMT component in a real-time basis. So to answer that question, is more than 500,000 of data. But the importance of the data will be we need sufficient variation of SMT different scenario to train that. So currently we able to achieve below 1% SKP rate in the production floor. Thank you.
Okay, now comes to our fourth question. Okay, so since there are many checkers in the programming, how it impact to the cycle time? I think this Marcus.
As for the AI checker, we don't actually run it during the inspection. But when does it actually run it? So whenever we reload a program, we modify a program which involve a save and load of the database. Whenever there is a change in database, we will recheck all the parameter. Means that it will be only apply the checking when we load or modify the database. So it don't have any impact on the cycle time. Yeah, thank you.
Well, more questions are coming in, so let me answer the fifth one. Okay, interesting. Is this AI feature available in your AXI systems also?
Okay. All right. Probably I could help to answer that.
Sure, thank you.
Yeah. So for AI feature, it is we are considered quite matured right now that we're able to run in multiple sites, customer sites for the AOI. Whereas for X-ray, we do have 1 to 2 customers that are currently under evaluation. The official release date is not yet confirmed, but I would say that we are in the progress with certain success rate in certain packages. So we will announce it probably later on in another 1 or 2 quarters. Thank you.
So to the next question, is this solution ready to use or test on site or still work in progress? So let me answer this question for the audience. So for us, we are now deployed in a few beta sites. So yes, please contact us, and if you are ready and we have the suitable timing as well as the sample size, so yeah, we can deploy at your site for beta as well. And probably the next question. How much time needed for the AI bio to retrain if new defect or new device is introduced? So I have Ku to answer this.
All right, so for the new defects or a new device introduced, so basically we take typically 2 to 3 weeks time to retrain. But we found that in the past, we basically retrain the AI model for every 3 days for the old approach that we are leveraging. But for the new approach that we are running in the production floor right now, we do not really require frequent training on new situation of the packages. So basically, the AI is able to capture the important feature based on the image that supply to the AI in a real-time basis. So we no longer retrain new packages or new scenario. The AI model itself will extract the information from the component based on the scenario to judge whether it's a good or bad. Thank you.
Now, the next question. When will the AI VVTS target to complete all the components type coverage?
Yeah, good questions. I think we also encounter this question from all the below 10 customer sites. So right now, we almost cover up to 60% of the different SMD defects and packages. So to complete that, we still need bad joint and some of the polarity coverage. So approximately, we are targeting end of this year to complete full coverage. So I think we are in a good progress right now. Thank you.
Okay, the next one, interesting. OCV are included on for AI programming. So is OCV included in the AI programming? So Marcus?
The easy answer there is a yes. And also, we also need some input from the user. Example, some of our customer, they have a list of what is the character or the words that need to be checked for which part number. So if this list can be provided, we will train the OCV automatically. It even can help when you have a part number change during a project, it can be automated. Thank you.
Okay, then the next question, since we have some time, because I think the last two questions we will go through. Okay, will the same machine, sorry, how to handle over reject and alternative part? I think this will be a good side, yeah.
Yeah, so yes, we do know that from the evaluation in the production floor, sometimes there will be some part changes in the production floor. So the approach today was when they start the productions, the AOI machine will automatically submit the good images to the AI as a reference. So whenever the AI detected there is the components that in a good shape, but the colors or some of the feature might change, but that is still a good component, good joint, there is no foreign materials and so on, then the AI will automatically request the next good component images from the AOI automatically. So this is how we handle the alternative part where the AI will actually request the alternate part images from the AOI automatically. So there is no user intervention needed over here. All right, thank you.
Perhaps the last question, and for the questions that we have not able to come back to you, we will record it down and then we will answer to you accordingly. Okay. Perhaps the last question over here. What are the basic infrastructures needed in order for customers to eval on site? Okay, maybe I'll answer this last one. So for us, we will determine the 3D AOI basic platform, and then for us will be on the ViTrox platform, the best case scenario. And in the future, we will also try it on to the non-ViTrox machine as well. So that's time to come. Okay. So with this, thank you for your time that is available, that's given to us for this webinar and also the Q&A questions. We are so delighted that we have answered. Give us so many questions that we are able to answer your questions. But please stay tuned. There will be more to come and then a lot more in the webinar series. Thank you very much.
Thank you.
Thank you. Thank you.